The name of the game at airports these days is security. And while X-ray machines and metal detectors can spot most potential problems, they can't catch a plastic explosive. For a machine to determine that an object inside a suitcase is a plastic bomb, it's got to be able to do fuzzy logic. That is, come to a quick decision based on incomplete, conflicting, or ambiguous data. Now, to do that, the FAA has turned to the brain-like power of neural network computers. Today, we take a look at the next generation of computer processing, neural networks, on this edition of the Computer Chronicles.
Computer Chronicles is made possible in part by Central Point Software, suppliers of utilities software, including disk backup, data recovery, file and desktop management, and virus protection. Central Point Software, making computing safer, simpler, faster. Additional funding is provided by the Software Publishers Association, which reminds you it's a federal offense to copy software, and by PC Connection and Mac Connection, and by Byte Magazine and Bix.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and with me this week is Jan Lewis. Jan, what we have up on the computer here is something called ExploreNet 3000. It's a neural network application program from HNC, and we're actually running a problem right now, a parity problem, and occasionally you'll see these little icons click there, and you can see it's processing different sessions of this particular problem. What's interesting is to look at the graph on the bottom, which is the mean square error as it's trying to solve this parity problem, and you can see it drop, a big drop in the middle at some point as the program, as the neural network system is learning how to do this, and of course reducing the number of mistakes it makes. Just one little example, we'll see others in just a minute. What I want to ask you is something I don't understand. If neural network processing is so different and so unique and depends on parallel processing, how do you just shove a disk into a PC and run it?
Good question, because in fact exactly what neural nets are trying to do is more closely approximate the way the human brain works. The human brain does many things at the same time, massive parallel processing. Give you some idea of scale, human brain in terms of, let's say, pattern recognition of an object is probably doing about a few 100 billion processes all at the same time. So the question is very good, how does it happen? Most of the software packages now are actually simulating the parallel processes, and in fact they're really going on a sort of time-sharing basis. Intel, however, has just introduced a chip that in fact is made for massively parallel processing things such as neural nets. And in fact on this one chip they basically have over 10,000 individual little computers that do in fact process in parallel.
Wow. Jan, today we're going to demonstrate several neural network applications that run on a 386 PC or on a Macintosh, and we're going to start out by looking at what's called a HAN, a higher order neural network. NASA has developed one such system to do pattern recognition, and here's our report from NASA's Ames Research Center.
An astronaut is responsible for the maintenance of the spacecraft once in space. But scientists at the NASA Ames Research Center are working on a neural network they hope will assist the astronaut in some of those tasks. In this computer simulation, the scientists are training the network, called the higher order neural network, to identify different types of airplanes. The network's main feature is its ability to recognize the same object, even if it's in a different position from the training set.
The neural network is trained in terms of triangles, where the triangle is a distortion invariant feature. That is, if you draw a triangle from any 3 points around the edge of an object, now you take that object and you move it, you rotate it, and you scale it, you find those 3 points that are in the same relative positions still form a triangle with the same included angles.
Thus, the neural network distinguishes between objects by identifying the different triangles in each. This distortion invariance is built into the architecture of the neural network and does not need to be learned. The scientists say this means the higher order neural network requires a shorter training time. It also achieves 100% recognition accuracy on the distorted views. NASA is also working on an optical version of the neural network. It hopes eventually to load the program on a space mission.
One of the main applications that we're looking at is in robotic vision, where an application where a robot will be sent out to try to, say, retrieve a tool in space, and it's necessary to be able to recognize the object in any view it could appear. It could be rotated, and it could be at an unknown distance and in an unknown position in the input scene, and it has to be recognized, and then the robot can go out and grapple the object.
For the Computer Chronicles, I'm Maria Gabriel.
Well, a spreadsheet is a wonderful business tool, but it is essentially a dumb tool. Add a pinch of neural network technology, though, and your spreadsheet can start making intelligent forecasts. Here to show us how are Murray Ruggiero Jr. of Promised Land Technologies, and also with us Mark Lawrence of California Scientific Software. Jan?
Mark, we've heard before about expert systems, and now we're hearing quite a bit about neural nets. They both really have the aim of having the computer do something that the human is good at. Now, what is the difference between these two methodologies, and are they mutually exclusive?
They're not exclusive at all. In a neural network, you're using history and past experience to try and deduce what to do in a given situation. With an expert system, you're using rules. My favorite example is traffic lights. The rules are stop on red, go on green. Yellow is very complicated. It depends on traffic, how fast you're going, where you are, if there's a policeman watching. There are no fixed rules for that. It would be very difficult to enumerate them, perhaps impossible. So, in fact, you could merge the two technologies. The simple decisions, stop on red, go on green, could be done with a rule-based system. The complicated decision for yellow, involving integrating data from all kinds of information places and sources, would be done perhaps with a neural network.
All right, Murray, talking about complicated things, you've got an Excel up there and dealing with all kinds of data. You've got millions of numbers up there. Tell us a bit about BrainCell and how you apply your approach to neural nets to dealing with spreadsheet data.
Okay, basically, up until BrainCell, neural networks have been for people who understood the technology. In order to train neural nets to do anything useful in real-world applications, it usually required a lot of tinkering. What we've done with BrainCell is simply to hide all those technical features and have the software take care of these adjustments for you.
I want you to show us an example, Murray.
Okay, what we're doing here is in a spreadsheet, you end up having times that you do everything with formulas. You want to do if-thens to see how it affects your business. Well, what happens if you don't know the formula? An example would be your business is heating and air conditioning. Selling that equipment to new constructions. If you know what the new constructions are, how many billions of dollars, you can judge your business. The question is, there's no equation to calculate that, but we do have data that's available from the United States government. So we could use a neural net to replace this missing equation and then have our other equations calculate through using BrainCell.
All right, show us how you do that.
Okay, what we would do is we would just pull down the data menu and hit BrainCell. We go create, and we type total new construction, file name, with 31 inputs and 1 output. When we wanted to train it, we would just highlight all this data and name it a range in the spreadsheet.
And briefly, what is the data in the spreadsheet? What kinds of things?
The data is gross national product in $1982, corporate tax burden.
Okay, so lots of basic government raw economic data.
Exactly.
Okay.
So now to train it, with other neural net tools, you have to set parameters like learning rate and momentum. Or they have constant defaults. And what happens is constant defaults don't work in real-world applications. And to set them requires knowledge. So we're just going to train this for 10 seconds just to show you how easy it is. That's it. It'll train, and you notice the icon, which is in blue, the numbers are changing and updating as this thing trains. This shows you the average error for the training patterns.
All right, so what have we learned now?
Okay, what we've learned is we have learned how to train a neural net and with BrainCell, and now what we're going to do with it is, if you notice, we had those two blank columns. Those two blank columns were the 2 years I pulled out here. You have to test a neural network on data that's never seen before. Otherwise, it's really useless.
Now, these are 2 years that weren't included in your data.
These were 2 years
right
that
there.
were not included.
Okay.
So what we did, in the same data, we pulled these out. Let's see how it does against this. Oops, sorry about that. Against this data. As you can see, it did a pretty good job of modeling it. 1.7, 3.9, 14, 14.6. But now let's say we have the government makes projections and say this is what these economic factors should be this year. You want to know how it affects your business if the government's wrong. So what you can do is you can use BrainCell to now simulate an equation. you would use our Ask Expert feature. You would add new range, which is what we just looked at. Hit Alt-D. And as you can see, for these set figures, this was what it said. There's a formula in here which tells me how much money I'm going to make based on here.
So you use the formula which the program created to apply to new data or theoretical data to see what the outcome
Right.
would be.
It isn't really a formula. It's a virtual formula. There's no formula in this cell, but it acts like one, as I can show you right here by, let's change the corporate tax burden and increase it to $113 billion, and watch what happens. And as you can see, all of a sudden, I am losing money instead of making money. So Brain Cell allows me to do if-thens in a spreadsheet when I don't know the relationships.
Mark, I want to turn to you. All right, now we've taken a look at Brain Cell. Tell us about what your product is and how the approach is different.
BrainMaker is a very mature product, which we have designed to be a standalone sort of program. Here I have an example of a neural network being trained to predict corn futures. Many of our customers are using neural networks, our neural networks, BrainMaker, to do currency and commodity futures.
Are financial applications the major application that you're seeing?
At this point, yes. We have about a 60% market share with our program, and about half of our customers are doing financial applications of one sort or another.
So again, what you're doing is looking at historic data here.
That's right.
And trying to figure out what's going on and how to predict.
Exactly. In this case, we're looking at sales of corn, the price of corn for 1 month back, 2 months back, and 3 months back, and we're predicting what the price of corn will be next week. Of course, information like that can be used to make money.
Yes. Okay, now it's still going through its learning process right now?
As we're learning, we're putting 2 graphs up on the screen that show us something about what's happening to the synapses, the connections between the neurons. It's now done training. Having finished training, we can now start making some graphs of what's going on here. We read in our data. This program here is something we call NetMaker. We give this away with every copy of BrainMaker. It's a spreadsheet. Many of our users are interested in integrating data from many sources. Other spreadsheets, Excel, Quattro, Lotus, database programs like DBase, binary files that came over a modem perhaps. This lets them bring those in from diverse sources and very quickly and efficiently produce neural network files. In addition to that, we allow them to manipulate the data. Often you'll find that you have data, but you want to do something to it. If you're a technical analyst, maybe you want to do log differences or moving oscillators. If you're working with historic data, maybe you want to take the data and do a time delay on it or run moving averages or something like that. In this case, what we'll do is we'll look at some of the results here. For example, here we'll look at the price of corn, which BrainMaker has produced.
We're going to see this in graph form now?
That's right.
And do you also test after you have trained the model?
Absolutely. In fact, we do more than that. One of the key features of BrainMaker is that what a neural network is doing during training actually is very analogous to memorizing. Memorizing is not what you're interested in. What you're interested in is generalization, the ability to make predictions. So what we do is we interrupt training at regular intervals and test the network and keep statistics. What this means is instead of choosing the network that memorized best, you choose the network that generalized best.
Mark Murray, we're out of time. Thank you very much. Well, we've seen so far neural network technology in the form of software, but as Jan said earlier, Intel is now selling an electrically trainable analog neural network chip known as ETAN. Here's a report.
In the race for faster processing speed, chip makers have looked at all sorts of new architectures from parallel processing to light waves. At the Intel Corporation, researchers have developed a neural network chip which processes information much like the human brain through connections called synapses. The chip can process 2 billion interconnections per second.
The chip's main advantage is its speed of performance. The time it takes a neural network chip to map or recognize an input pattern can be microseconds compared to milliseconds to seconds for a computer, a standard conventional computer.
The chip is called the 8170 Electrically Trainable Analog Neural Network, or ETAN. ETAN's 64 analog neurons replicate the basic functions of the brain. The neurons can process data by giving each input a numerical weight. This chip can accommodate over 128 inputs and store over 10,000 synaptic weights. Experts here are programming the chip to recognize and catalog the tiny serial numbers on film strips. But before that can be done, they have to train a simulation program called BrainMaker. It's part of the ETAN's development kit and emulates the characteristics of the chip. The software here is learning to recognize the serial numbers. A solid bar means its training is complete. The synaptic weights are then downloaded from the program onto the ETAN. Intel isn't the first to develop a neural network chip, but there are key differences with the other products.
It's all analog, for one thing. It handles analog voltages as input and output, and all the processing on the chip is done in analog. Another interesting characteristic is that it uses non-volatile memory to store the weights. So when the power is turned off, the chip still remembers what you taught it, or if you will.
But if the power of one ETAN is not enough, Intel also has a multi-chip prototyping board that can hold up to 8 neural network chips working in parallel. For the Computer Chronicles, I'm Maria Gabriel.
Neural network products are available for the Macintosh as well as for the PC. And to show us MacBrain and NeuroSmarts are Matt Jensen of Neurix, Dr. Richard Mansfield of Cognition Technology Corporation. Also with us, Tom Schwartz, consultant and analyst in the field of neural networks and artificial intelligence. Jan?
Matt, now your program, MacBrain, has a new approach. You have a wider variety of algorithms. You support a HyperCard front end. Show us MacBrain.
Okay, Jan. MacBrain is designed to be easy to use even on difficult problems. So what we can do is create a new network from scratch using Macintosh tools. Like, for example, we can create some neurons here, and then we can connect them together in a variety of different ways, including using tools that work on groups of units all at once. And then from that standpoint, we can make more complicated networks by using the cut, copy, and paste routines that are standard in Macintosh programs. And then we can build up more complex networks based on smaller modules, and that saves a lot of time. We also have a built-in macro language, which allows you to set up complex experiments or complex networks automatically, train data, because neural network problems of any serious size often take hours or even days to train on microcomputers.
Yeah, Matt, show us an actual application if you have using MacBrain.
Sure. Let me call up a new file here. This would be a program which would, or rather a network, which would analyze a loan application to determine if the person is a good risk or not. So we have inputs such as age, income, the equity they have in their house, and so forth. And initially the network knows nothing, but we'll train it on a bunch of case histories, people with different characteristics and what their payment history was. Now we've loaded in some data there, and we can access individual cases and analyze them. Then we can use a macro to automatically train the network. So let me just call up a little graph here, which we can use to keep a visual eye on how the network is progressing. I'll call that error, and the error should decrease, meaning that it's learning the relationships inherent in what makes a good risk as time goes on. So I think we're all set to go now here, and I'll just go to the macro menu and say run. And it'll start executing this macro here, which learns a number of times, and then after it's learned for a while, it'll update the graph and then go back.
Curve coming in.
Right, and then the error curve here is starting to drop down, and we can zoom in and do all kinds of graphs and analysis and so forth. What we can also do is, after the network has trained for a while, we can use another part of this macro here, starting here, which, when we run it, will allow us to test an individual case. So, for example, we can say someone who's 25, male, so forth, married, makes $30K, and rents. They have no equity in their home, and they want to ask for $20,000. From what the network has trained on so far, it thinks that person's a good risk. Now, once you've developed an application, you can then sort of download the system into a runtime engine which runs within HyperCard or Fourth Dimension, other Macintosh applications.
All right, Matt, I want to ask you to get out of MacBrain if you can. We want to take a look at NeuroSmarts. And Richard, while he's doing that, what's the approach of NeuroSmarts? We've seen 3 different approaches here to using neural network technology. What does NeuroSmarts do?
NeuroSmarts is a unique hybrid product. It evolved from an expert system. And when customers like Hughes Aircraft asked us to add a hypertext front end so they could work with Navy maintenance managers, we added a hypermedia aspect to it. Then we found customers such as Blue Cross Blue Shield wanted to take a look at cost containment, so we added a neural net component. So now we have both neural net, expert system, and hypermedia.
Or let's fire it up so we can take a look.
Now, you have facts, rules, and advice. Let me go to a specific application here, and I'll show you exactly how that works. You can customize the front end. That's the hypermedia aspect of it. Now let me go inside the program. You can password it.
So we're going to do another example of really a loan analysis situation,
It's
Richard?
a loan analysis, exactly. Now, inside here, you can see that there are rules. The rules are basically if-then type rules, asking specific questions here. Down here, after you've collected the information you need for the neural net, you have the neural net component here, and let me just show you how that works. You have a data file, a validation file, and you can just let it go ahead and train. And it's very quick, shows you have a 93% accuracy. There's one particular discrepancy here. You can take a look at that if you wish. Now, let's go back out of here, and after answering those questions, let's see what it would come out with here. We'll just take, this is the test here, and we'll go on, and it says that you have, that loan would be a profitable loan to the bank, and we can go ahead and see what it would give in terms of a response. What you can give is not only an answer, but you can also give the loan agreement that you would get, and you can print that out. It's a printable document. So you can link both documents and rules and nets.
Let me get you into this now. We've been watching several examples here of using neural network technology to solve problems. What is the difference in what we've seen and the non-neural net approach, normal statistical analysis run the old-fashioned way?
All right. Normal statistical analysis, first of all, requires that you be a statistician. People look at neural nets as biologically motivated statistical analysis or statistics for non-statisticians, so that neural nets have the capability of analyzing very complex relationships without an understanding of the underlying problem that you're trying to solve. Typically in statistics, you need some understanding of the data before you try and analyze it. So it opens up powerful approaches to non-statisticians.
All right, I'm sorry, go ahead, Jen.
The algorithms that we've seen here, we've seen back propagation, and there's a couple of other of them. How much do any of them actually approximate the way the human brain works?
Well, you have to remember, Jan, that the human neuron has about 150 different processes going on. The neural nets that we've seen here model approximately 3 or 4 of those processes. Now, this is a first-order approximation. It does create economic value, so the issue of biological plausibility is really left more to the biologists than the people who are trying to commercialize this technology. Direct answer to your question, very, very rough first-order approximation, and to say that we can even say that or know that is difficult.
Tom, last question. We've seen some impressive products here, and we've heard about neural networks for a long time. How real is all this? I mean, are products out there? Are people using these things?
Oh, absolutely, Stuart. There's an installed base of almost 50,000 neural net products out there for the PC, Mac, and Sun kinds of platforms. There are people using them on a daily basis. In fact, every time you make a phone call, a long-distance phone call, you go through a one-neuron neural net. So that they're in daily use. I know we saw TNA at the beginning of the show. There are a number of people doing loan advisors, and certainly the financial forecasting is very, very hot area.
All right, gentlemen, thank you very much. That's our look at neural networks. Stay tuned now for this week's Computer News.
In the random access file this week, MicroSlate is introducing a new notebook PC that uses a pen as an input device. The Data Lite 300L PC features a touch-sensitive input screen on which you enter information using either a stylus or your finger. The new MicroSlate laptop will come complete with VGA screen, 1 megabyte of memory, and 20 megabyte hard drive. The price is $6,000. The first units are scheduled to ship in July. Lotus Development has announced the release of several new upgrades to 1.2.3. Version 2.3 for older DOS machines is now out. Lotus says it has many of the features found on the higher-end Lotus release, version 3.0. And Lotus now says the upgrade to that version, release 3.1 Plus, will ship by early July. InfoWorld magazine says that Microsoft is ready to roll out its long-awaited 5.0 version of DOS. The upgrade for current DOS owners will cost under $100, and release is expected in mid-June. Taking a look at this week's top 10 software titles for the PC, PC Connection reports that DR-DOS competitive upgrade to 5.0 is in the #1 position, with Expanded Memory Manager in second. Third is WordPerfect 5.1, followed by Windows 3.0. Procom Plus is in 5th place. Rounding out the top 10 PC titles are Adobe Type Manager for Windows, the Norton Utilities, Quicken, PC Tools Deluxe, and Norton Antivirus. And it's time now for this week's software review with Paul Schindler.
If you're tired of Rolodex cards and ready to get rid of them, you know there's lots of Macintosh programs that try to help you organize your address book. The best I've seen is a desk accessory called TouchBase. Now, usually you have to choose between a program too simple to do the job or a database too complex to handle. TouchBase is the best existing compromise between these two. First of all, it's a desk accessory, which makes it easy to get into. It's fast. Display a list, click on a name to bring up the full record. You can move forwards and backwards with these buttons. You can find a card by any of a number of criteria, including any field on the card. You can even search notes, but that takes longer. You can sort the listing almost any way you want as well. It has several handy, well-thought-out options for output, including envelopes, detailed forms, and listings. I was particularly impressed with the fax cover sheet and with the label section, which allows a choice of label types and enables you to start at any label on the sheet. TouchBase is $125 from After Hours Software in Van Nuys, California. For the Computer Chronicles, I'm Paul Schindler.
Radio Shack has announced a new trade-in program on new Tandy computers. If you buy selected 286 or 386 machines, Tandy will let you trade in your old computer. They're offering a credit of up to $500 for trade-ins. Radio Shack says the trade-in offer will be good until the end of June. Apple is also offering trade-in deals on new Macintosh computers at selected stores around the country. And finally, have you ever forgotten to save a file only to realize later that you really needed it? Well, a company called Working Software has come up with a miracle for you. It's called Last Resort, and it automatically records all computer keystrokes so that there's always a saved version of any computer input. Last Resort works as a TSR, and you can call up the magically saved files from inside most word processors. Last Resort is available only for the Macintosh. The cost is $50. That's it for this week's Computer Chronicles. I'm Kate McGargy.
Computer Chronicles has been made possible in part by Central Point Software, makers of Central Point Antivirus, a comprehensive program for the detection, removal, and prevention of more than 500 computer viruses. Additional funding has been provided by the Software Publishers Association, which reminds you it's a federal offense to copy software, and by PC Connection and Mac Connection, and by Byte Magazine and Bix, the Byte Information Exchange.